All right, we are into week 5. This week, you guys should have spent the beginning part of the week focusing on finishing up that portfolio. So again, a portfolio is just a quick summary in your own words, okay? So it does not have to be what I've said. It does not have to be what other classmates would say. It's you summarizing what you think the topics were from our previous unit, okay? So topics on your matrices and solving systems of equations. Just give me a brief overview, okay? You can do bullet points. You can do a sentence or two. It probably would take more than one sentence, so you might have to have a little bit more in explanation. Just giving a brief overview of systems of equations and matrices, the 4 different topics, and then maybe an example or two to demonstrate that you know how to actually solve that problem. Okay, so portfolios, just another way of assessment, just for me to see that you're understanding the content and the material. We are starting our calculus unit. Okay, I am very excited for this unit. I know there are a decent bit of you that will not be taking AP Calc next year, and that's fine. The stuff that we're going to be learning and practicing will still be beneficial for you guys as you're preparing to take your SATs, as you move into a college course, or even as you're planning on taking statistics or personal finance next year as well. Okay, so some of these resources that we're moving into and the units and topics will have some more calculus material, but some of the behind the scenes or like the prior knowledge that you need to solve that problem will be from algebra and some of your pre-calc skills. Okay, so this will be some just expanding upon what we already know with that. So what we're going to look at today, and we're going to start very slow with some of the material. As always, email me. We can set up some Google Hangout times if we need to go over this. But we are looking at finding limits. So that's a topic that we're looking at with calculus right now, analytically. So analytically means like an equation, plugging a number into an equation. So we have these 2 things that we're going to look at using substitution. So that's like when we're solving an equation, x equals 3. You plug 3 in for x. That's your substitution. Or algebraic method. So that can be factoring, canceling out. Okay. Next week, we will look at kind of applying this and also looking at some graphs with that as well. So here are just some different rules. Okay. They're similar to some rules that you've seen with other problems as well. Okay, a limit function is set up algebraically or analytically in this format here. Okay, and that reads limit as x approaches c x approaches c of f of x. So f of x is your function. Oftentimes we'll represent that with either a graph or an equation. Okay, and then as x approaches c, this little x with the arrow at the bottom tells you that we're plugging in a constant number. So a constant is just a regular number in for x. Okay, so if we have 2 different limits here, there's a couple different rules that we can use. Constant rule. So instead of having f of x or a function after your limit, if you just have a number, your limit will always equal that number. Okay, so let's say we had limit as x approaches 3 of 2. Okay, so you don't have an equation really to plug in 3. The only thing that you have for your equation is 2. So if it's always just a number, your solution to this problem is always going to be 2. Okay, kind of in a different approach, let's say we had as x approaches 3 and then your equation was simply x. Substitution, or finding it analytically, means we just plug that value 3 in for x. So if I plug 3 in for x, my solution is just going to be 3. So my constant terms will match up. You have this sum rule, meaning if I have the limit of 2 different functions, I can kind of separate them, or I can, going back to distributive property, can kind of distribute that limit to each of those functions separately and then add the answers together. Okay, we'll look at a few examples. You have difference rules, same type of process, except now you're subtracting. Okay, and you have your product rule, which is multiplication. Same type of thing. We can distribute that limit and take the limits separately and then multiply them together. Okay, we have a few more rules with this. Constant multiple rule. Okay, so if here's my function, an equation or something like that, and I want to multiply it by a number out in front. Okay, I can just kind of move that number out to the front and just take the limit of my equation and then reattach or reapply that multiplication of the constant. Okay, so that could look something like, so here would be my f of x function. What I'm allowed to do is bring this 2 out in front, and then I can just do the limit as it approaches this x minus 3 equation, and whatever answer I get, then multiply it by 2. Okay, we have our quotient rule, which if we're dividing or you have a fraction, again, we can kind of split that up, take the limit of the numerator, the limit of the denominator, and then whatever answer you get, you can go ahead and divide it. Okay, power rule, if you have an exponent, you can first take the limit of your function. Okay, let's say you get an answer of 2. Then you can raise that to whatever number you have in your exponent. Okay, so a lot of these rules are just allowing us to kind of rewrite and separate some of these functions in order for us to actually do the algebra behind the limit. Okay, so a limit is, and we'll look at this more graphically next week, you'll kind of see what it means, but we're looking at substitution right now. And so substitution and solving it analytically is simply plugging in a number and getting a value for that. Okay, we just have a little bit different of a function out in front. Okay, and then we also have the square root. So we can bring the limit underneath the square root sign and solve it first that way as well. So let's look at a few examples here. We have 2 different limits. So we say, suppose that your limit as you approach c. Okay, so for this example, we're not actually putting in any number for c. So as we approach any constant, f of x is going to equal 4, and g of x is going to equal a negative 3. So what we're going to do is we're going to split up each of these terms, then we're going to plug the numbers in and solve it analytically. Okay, so because of the properties that we just saw earlier, I can go ahead and kind of take the limits separately. So basically what I'm doing is distributing this limit to each of my functions. Now I have limit as x approaches c of f of x, and we already saw up here that that's going to equal 4. So all I'm doing is substituting that out for 4, plus limit as x approaches c of g of x, which is a negative 3. So now I'm adding a negative 3. I can simplify that, and that gives me a value of 1. That's your final answer. Okay, we are not going to do all of these problems with limits. We'll probably finish these 4, and then there's a few on another slide that I can just give you the answers for so you can see them. But all these properties are kind of going into play with this. So for this one here, we can separate this. We're going to do it in a couple different steps so you can see all that I'm doing. So I can break this up and just distribute that limit sign to each of them. Okay, so now I have a function, f of x and g of x, but I have a constant number out in front. So I'm allowed to bring that constant number, I'm just going to move it out to the front, so I have 3 times whatever value I get as my limit of x approaches c of f of x. And then I'm going to do the same thing here for my g of x function, move that 5 out to front. Okay, if you kind of remember to when we were looking at the expanding and condensing, and we had to kind of separate and break every little piece apart, that's kind of happening with the limits as well. Now, some of them you might be able to quickly just realize what the answer is going to be and solve it. Okay, but this is kind of showing you the reason behind why we can do that. So now we're going to substitute in the value that we found for the limits. So I'm going to plug in, this one is 4. And then I have 5 times a negative 3. So I have 12 minus a negative 15. So when I simplify and add those together, I get 27 as my final answer. Okay, go ahead and pause this here and go ahead and try C and D on your own. Look back to the slide on the different properties with limits and see if you can do it on your own. And then check back here to see the answers. Okay, so hopefully you paused the video and tried these on your own. In the box, you'll see the answer, negative 84 for C and negative 8/3. Okay, for D, you also could have gotten the decimal for that as well if you wanted. And that would have been 2.67 if you're rounding, negative 2.67. Pay very careful attention to problem C. you have this 7 that's being multiplied to f of x and g of x. So that 7 has to come all the way out in front, and you need to do the multiplying, okay? It really shouldn't matter how you multiply them at the end, but just pay attention to that property there in case it was a subtraction property or something. All right, so moving on, substitution theorem is when you have an equation or a rational function, you can substitute the value into the function as long as your denominator does not equal 0. Okay, so all that we're doing with limits and substitution is simply plugging the number in for x and getting a value. Okay, so it's just set up a little bit differently. And as we start to get further on in the unit, you'll see some different properties, but for right now, you're just plugging a number in. So this equation here, we would plug -1 in for x. Okay, I make sure that, especially because it's negative, everywhere that I plug it in, I put it in its own separate set of parentheses. And then I'm just going to simplify. So I have -1 plus -1 squared is going to become positive, so that'll just be 2. This becomes +5 and +4. And then we're simply going to add those all together. So this will simplify to 10, just plugging values in. Okay, so that one was pretty easy enough. But if we look at an example like problem B here, first thing that we want to do is we can go ahead and plug in your value for x. So it's a 3 squared minus 6 times 3 plus 5 all over 3 plus 3. And then we're going to simplify. Notice that we don't get 0 here on the denominator, so we're fine. We can keep on solving however we want for this one as well. Okay, so after simplifying this, I get an answer of -2/3, and that's my limit for this function. Go ahead and try the problem for part C on your own. Okay, pause the video and check back here in a little bit when you finish to make sure that your answer matches up with what I have. Okay, hopefully you paused it and solved it on your own. You should have gotten an answer of 5 for that one. Okay, check the work if you're stuck. Email me if you have any questions. We have one more type of problem that we're going to look at. And this happens often when you get 0 on the denominator. Okay, so if I were to plug in this 2 for this equation here, what's going to happen is that I'm going to get 0 on the denominator. Okay, I'm not really concerned right now with what's on the numerator. When I simplify that, I end up with 0. And you guys know from algebra, pre-calculus, all of that, that you cannot divide by 0. So anytime when you do the initial substitution and you get 0 on your denominator, you need to go back to your original problem and see if you can factor and cancel anything out. So that's what we're going to do now. Okay, so go ahead, pause this, try factoring it on your own. Okay, so I factored it out. We have a difference of perfect squares on the denominator and a trinomial on the numerator. This allows me to cancel out my x minus 2. So now I have an x plus 3 over an x plus 2, and I'm going to do substitution again. So I plug 2 in on my numerator and 2 in on my denominator. And my answer then is 5 over 4. Okay, there will be a few cases when even after you cancel out and do substitution, you're still getting 0 on the denominator. And we'll get to those problems later on. Your limit's just not going to exist for that problem. Okay. So you can go ahead and try this second one on your own. Again, then check back here and see if your answer matches up with mine. I'm going to tell you right now that you do need to factor and cancel out, because if you originally plug 3 in, you will get 0 on the denominator. Okay? Okay, so hopefully you factored that. The top factors to x minus 3, x minus 8. Your denominator factors to x plus 5, x minus 3, and then you're able to cancel out. And then once you cancel it out, we're doing this process here at the bottom to plug in, direct substitution, plug in 3 for x and simplify, and then you get a -5 over 8. You guys will be getting a worksheet on this. I will tell you what problems I want you to practice. It's going to be either using the properties like we looked at in this slide here and just simplifying, or doing substitution like we did with these problems here. Do not worry about anything with graphs. You will see that next week. Okay, if you're struggling with it, it's okay. Give me until the end of next week to kind of re-explain and see some different methods. But email me with any questions. Keep working on it. You guys are doing great. Have a great rest of your week.